Hello my schoolers, you're welcome to my school YouTube channel and my name is Frank. In today's video we shall be tackling JAMB CBT physics past question for the year 2005. Please relax, do not go anywhere, I'll be right back. You are welcome back to my school YouTube channel. In today's video, we shall be answering question 1 to 25. So let's kick off with question 1. Marching soldiers crossing a suspension bridge are usually advised to break their steps to avoid damaging the bridge owing to A. Oscillation, B. Resonance, C. Swinging, and D. Vibration. So the answer to this question is option B, which is resonance. And the reason for that is because when soldiers march in uniform crossing a suspension bridge, their footstep actually creates vibration, which matches the natural frequency of the bridge. This phenomenon known as resonance actually amplifies the vibration, okay, which potentially damages the bridge. So in order to avoid this, they are asked to break their steps when crossing a suspension bridge. So that makes option B the correct answer to this question. Question 2. The sharpness of the boundary of the shadow of an object is determined by the A. Intensity of light striking the object, B. Rays of light passing through the object, C. Nature of the object, and D. Opacity of the object. So the answer to this question is option A, intensity of light striking the object. So the characteristic of cast shadow are dependent on the intensity of the light striking the object. Hard light produces cast shadows with sharp edges, while soft light produces cast shadows with blurry edge. So that makes option A the correct answer to this question. Question 3. A thin converging lens has a power of 4.0 diopters. Determine its focal length. Okay, so remember that the power of lens is given as P is equals to 1 all over focal length. Okay, but here the focal length must be in meters. But if it's not in the meters, then you'll be having 100 over F, indicating that this F is in centimeter. Okay, but in this question we are asked to calculate for the focal length, so we just switch position with the power of the lens. So here we'll be having F to be equals to 1 over P. Okay, so we just substitute the value of P. So here we'll be having 1 divided by 4, which will be equals to 0.25 meters. Okay, so the answer to this question is option D, 0.25 meters. Question 4. A real image 3 times the size of an object is formed 24 centimeters from a converging mirror. What is the focal length of the mirror? So let's move over to the board to provide answer to this question. So in this question, we were told that magnification, even though the word magnification is not mentioned, okay, the magnification equals to 3, while image distance equals to 24 centimeters. Okay, so from there we can actually calculate for object distance. Okay, since we are looking for focal length, and focal length is given as 1 over F is equals to 1 over V plus 1 over U for mirror. Okay, so this is our mirror formula. So we need to first of all get the value of U. Okay, so to get the value of U, we simply use our magnification formula, which is M is equals to V all over U. But here M is equals to 3. Okay, and we are looking for U, so we just switch position with M so that U is equals to V all over M. So we just substitute the values that are given to us. So for U we have 24, while for M we have 3. So if we divide, here we'll be having U to be equals to 8 centimeters. So now that we've gotten the value of U, then we can just substitute it here to calculate for the focal length of the converging mirror. So here we'll be having 1 over F is equals to 1 over 24 plus 1 over 8. Okay, so the LCM of 24 and 8 is 24. Okay, so 24 into 24 will be 1, so 1 times 1 is 1, then plus 8 into 24 is 3, then 3 times 1 is still 3, okay? So if we add the numerator, we'll be having 4, while the denominator still remains 24, okay? But we are asked to calculate for f, okay, not 1 over f. So in this case, we just have to cross multiply, or we just invert. So here we can say f is equals to, then we invert the other side. So we'll be having 24 divided by 4, and this will be equals to 6 centimeter, okay? So the value of the focal length of the converging mirror is equals to 6 centimeters. So let's return back to the screen to pick the correct answer to this question, and that is option B, 6 centimeters. Question 5. The pair of physical quantities consisting of vectors only are. So remember that vectors are quantities that have both magnitude and direction. Okay, so let's go through the option. For option A, we have momentum and power. So momentum is a vector quantity, but power is not a vector quantity. Option B, velocity is a vector quantity, but distance is not a vector quantity. Option C, displacement is a vector quantity because it has to do with distance, travel in a specified direction, and torque also, which is force, is also a vector quantity. Okay, while option D, acceleration is a vector quantity, but speed is not a vector quantity. So the pair of physical quantity consisting of vectors only is option C, which is displacement and torque. Question 6. In an ideal wheel and azo system, R stands for the radius of the wheel and small letter r is the radius of the azo. The mechanical advantage is, so the mechanical advantage of wheel and azo system is given as arrow all over small r, okay? So where big arrow here stands for the radius of the wheel and small arrow here stands for the radius of the azo, okay? Which makes option D the correct answer to this question. Question 7. An object is projected from a height of 80 meters above the ground with a velocity of 40 meters per second at an angle of 30 degrees to the horizontal. The time of flight, okay, so we are asked to take g to be equals to 10 meters per second square. So let's move over to the board to provide answer to this question. So basically, for calculating for time of flight, we are to use t, which stands for time of flight, is 2u sine theta all over g. Okay, so here we just substitute the values that are given to us. So that we'll be having 2 times, which is our initial velocity is 40, then sine 30. Okay, here will be sine 30, then divided by 10 because we are asked to take g to be equals to 10. So, but remember that sine 30 is equals to 0.5. So here we'll be having 2 times 40 times 0.5. Remember, 0.5 means 1 over 2. Okay, all over 10. So these 2 we cancel out these 2, and this 0 we cancel out this 0, so that we'll be having 4. Okay, so the time of flight is equals to 4 seconds. So, but you must remember that this object is projected from a height, okay, from a height 80 meters above the ground. So, but in this question, if we are to calculate the total time the object actually spend in air, then that will include the time it takes the object to fall from the height of 80 meters, okay, to the ground. So if we are to go by that, then our answer wouldn't be 4 seconds. But going by the option that is given to us, okay, the answer is equals to 4 seconds. So let's return back to the screen to pick the correct answer to this question, and that is equals to 4 seconds. And probably, maybe in this question, they also assume that the object fell back to the point of projection, which is the 80 meter, meaning it did not fall to the ground. Okay, so that is why the other answer was not added to the option. So that makes option B the correct answer to this question. Question 8. In an AC circuit that contains only a capacitor, the voltage lags behind the current by A, 180 degrees, B, 90 degrees, C, 60 degrees, and D, 30 degrees. So the answer to this question is option B, 90 degrees. So in an AC circuit that contains only a capacitor, the voltage actually lags behind the current by 90 degrees. Or you can say that the current leads the voltage by 90 degrees. So what this means is that when the current gets to its peak values, the voltage across the capacitor will approximately be equals to 0 and vice versa, okay? So that makes option B the correct answer to this question. Question 9. The time it will take a certain radioactive material with a half-life of 50 days to reduce to 1/32 of its original number is. So let's move over to the board to provide answer to this question. So to solve this question, we'll have to use the formula N is equals to N subscript 0, then bracket to put 1/2, then raised to power T divided by 1T 1/2. Okay, so the T 1/2 here means half-life, and the T here, capital letter T, is actually the time we are looking for. Okay, so the N here actually stands for the mass of the material that is left after the material has undergone decay. Okay, while N naught here represents the original mass of the material. So in this case, it's actually assumed to be 1. Okay, so if our N here is equals to 1/32, then this is 1. So here we'll be having 1/2 raised to power T, which is actually what you are calculating for, all over the half-life, which is 50. Okay, so here we can express 1/32 in index form in such a way that the base, okay, will also be equals to 2. So if we do that, we'll be having 1/2 raised to power 5. Remember that 1 raised to power 5 is still 1, then 2 raised to power 5 is 32. Okay, so what we have here, 1/32 is equal to 1/2 in bracket raised to power 5. Okay, so this will be equals to 1/2 in bracket raised to power T over 50, right? Now, according to the law of indices, since the bases are the same, we can actually equate the powers. Okay, so if we equate the power, we'll be having 5 to be equals to T all over 50. Now, since we are looking for the value of T, we just cross multiply. Now, remember that this 5 is also over 1. It doesn't change anything, okay? So we just cross multiply to get the value of T. So if we cross multiply, we'll be having T to be equals to 5 times 50, and this will be equals to 250 days, okay? So the time it will take the radioactive material to reduce to 1/32 of its original number is 250 days. So let's return back to the screen to pick the correct option for this question, and that is option A, 250 days. Do you know you can take practice questions with our JAMB simulated CBT past questions? All you need to do is to click on the link in the description below, and that will take you to my school website. There you will need to download my school mobile app for your Android devices and my school software for your laptops and computers. Please go ahead and start practicing. Moving on to question 10. A proton moving with a speed of 1.0 times 10 raised to power 6 meter per second through a magnetic field of 1.0 teslas experiences a magnetic force of magnitude 8.0 times 10 raised to power minus 14 Newton. The angle between the proton's velocity and the speed is, so we are asked to take Q to be equals to 1.6 times 10 raised to power minus 19 coulomb. So let's move over to the board to provide answer to this question. Now remember that for a magnetic force F, okay, is given as Q times V times B sine theta. Okay, so in this question we actually asked to calculate for sine theta. So remember that here Q here represents the quantity of charge, okay, while V here represents velocity, while B here represents magnetic flux given in Teslas. Okay, so since we already know these values, it's just for us to substitute. So our F, which is our magnetic force, is given is equal to 8.0 times 10 raised to power minus 14, and this will be equals to the quantity of charge, which is 1.6 times 10 raised to power minus 19, then times velocity, which is 1.0 times 10 raised to power 6, then times the Tesla, which is the magnetic flux 1, okay, 0.0, then sine theta. Okay, so since we are looking for sine theta, we just make it the subject of formula by dividing both sides by the coefficient of sine theta, which is everything we have here. Okay, so that sine theta will now be equals to 8.0 times 10 raised to power minus 14 over 1.6 times 10 raised to power minus 19 times 1 times 10 raised to the power 6 times 1. Okay, so if I multiply this whole thing by 1, it still remains 1. Now, if I multiply 1.6 by 1, okay, it still remains 1.6. So here we just apply the law of indices to tidy up this place here. So if we do that, we'll be having minus 19 plus 6, okay, since we are dealing with multiplication. So in this case, the powers we add. So you'll be having minus 19 plus 6, and that will be equals to minus 13. So on the numerator still remains the same, which is 8 times 10 raised to the power minus 14. Then the denominator is now 1.6 times 10 raised to the power minus 13. Okay, so 1.6 into 1.6 will give us 1. Then 1.6 into 8 is going to give us 5. Okay, so here for 10 raised to the power minus 14 and 10 raised to the power minus 13, we still apply the law of indices. Okay, so if we apply the law of indices, we'll be having 5 times 10 raised to the power minus 14, then minus, which is because of the division sign, then minus 13. But remember that minus is going to change to plus. Okay, so here we still have 5 times 10 raised to the power minus 14, then plus 13. So minus 14 plus 13 is going to give us minus 1. So we have 5 times 10 raised to the power minus 1, okay? And 5 times 10 raised to the power minus 1, let's continue from here, okay? And 5 times 10 raised to the power minus 1 is still the same thing as 0.5, okay? So sine theta is equals to 0.5, right? If now this is in standard form, so if we are to move it to, if we are to write this in ordinary form, it simply means that the invisible decimal point that's in front of this 5, we should move it one place to our left, so that will give us 0.5. Okay, so but we are looking for, in this question we are looking for theta, not sine theta, so we have to take the sine inverse of both sides, so that theta is now equals to sine inverse of 0.5. Okay, and the sine inverse of 0.5 is equals to 30 degrees. So let's return back to the screen to pick the correct answer to this question, and that is option C, 30 degrees. I believe you are enjoying this video content. If yes, please do not forget to hit the like button, click on the subscribe button, and lastly, tap on the notification bell to get informed as soon as we release the next videos. Question 11. When impurities are added to semiconductors, the conductivity of the semiconductor A increases, then decreases, B increases, C decreases, and D remains constant. So when impurities are added to a semiconductor, it's actually called doping. Okay, and the essence of doping is because you want to improve on the electrical conductivity of the semiconductor material. Okay, so when impurities are added to semiconductor, what you are trying to achieve is that you are trying to increase the conductivity of the semiconductor material. So when impurities are added to a semiconductor, the conductivity of the semiconductor will increase. Okay, the conductivity of the semiconductor will increase. So that makes option B the correct answer to this question. Question 12. A silicon material is doped with an element of a certain group and an n-type semiconductor is formed. The most likely group of the elements is A, 5, B, 3, C, 1, and D, 2. Okay, so if you want to achieve an n-type semiconductor material, you simply need to dope the silicon material with an element that has more electron on its atomic share than the silicon material. Now remember that silicon materials has 4 electrons on their atomic share. In order to dope it, okay, so that you achieve an n-type semiconductor, you have to dope it with an element that has more elements on its atomic share than the silicon material itself. So in this case, you are going to be using element from group 5. Okay, so that makes option A the correct answer to this question. Question 13. The charge carriers in gases are A, ions only, B, electrons and ions, C, electrons and holes, and D, electrons only. So the answer to this question is option B, electrons and ions. Okay, so when gases undergoes ionization, the atoms of those gases are freed of electrons, and these electrons are free, okay, to move about and carry electric charges, while the atom of the gas that have lost an electron automatically becomes an ion, and those ions too are free to move, okay, and to carry electrical charges. Okay, so that makes option B the correct answer to this question, electrons and ions. Question 14. The ray which causes gas molecules to glow is known as A, cathode ray, B, anode ray, C, molecular ray, and D, gamma ray. So the answer to this question is cathode ray. So cathode rays are stream of electrons that can excite gas molecules, causing them to emit light. Okay, so the ray which causes gas molecules to glow or emit light is known as cathode ray. So that makes option A the correct answer to this question. Question 15. A transformer is rated 240 volts if the primary coil is 4,000 turns and the secondary voltage 12 volts. Determine the number of turns in the secondary coil. So let's move over to the board to provide answer to this question. But remember that the voltage in the primary coil is equals to the number of turns, okay, in the primary coil, okay, and this will be over the voltage in the secondary coil all over the number of turns in the secondary coil. Okay, so here we are looking for the number of turns in the secondary coil, so we just make it the subject of formula. Here in this case, since we have two fractions that are equated to each other, we just cross multiply to make ns the subject of formula. So ns will be equals to np times vx all over vp. Okay, so here we just substitute the values that are given to us. np, which is the number of turns in the primary coil, is given to us to be equals to 4,000. This will be multiplied by the voltage in the secondary coil, which is 12, all over the voltage in the primary coil, which is 240. Okay, so 0 will cancel out 0, 12 here 1, 12 here is 2, 2 here is 1, and 2 here is 2. So at the end of the day, we have 200 tons, okay, meaning that the number of tons, okay, the number of tons in the secondary coil is equals to 200 tons. So let's return back to the screen to pick the correct answer to this question, and that is option A, 200 tons. Question 16. The current in a reverse bias junction is due to A, minority carriers, B, electrons, C, majority carriers, and D, holes. So the answer to this question is option A, minority carrier. So the current in a reverse bias junction is due to minority carrier. So the minority carrier in a reverse bias junction, okay, the minority carriers there are electrons in the p-type, okay, material and holes in the n-type material. So that makes option A the correct answer to this question, minority carriers. Okay, but also remember that in a reverse bias junction, okay, the positive terminal of the battery is connected to the n-type material, okay, and the negative terminal of the battery is connected to the p-type material. So at the p-type material, you'll be having a few number of electrons, so in that case it becomes the carrier, while on the other hand, on the n-type material you have few numbers of holes, so in that case it also becomes the carrier in the case of reverse bias junction. Okay, and that is the reason why option A is the correct answer to this question. Question 17. Which of the following materials is a conductor? So remember that conductors are materials that allows electrons to flow, or that allows electric charges to flow through them. Okay, that allows electric current to flow through them. Then conductors too, they also allow heat to flow through them. So A, we have glass. Glass is not a conductor. So we have wax. Wax is not a conductor. We have sodium. Then we have plastic. Plastic is not a conductor. So the answer to this question is sodium. So remember that sodium is a soft metal. Okay, and sodiums are conductors. Remember that metals are conductors. They allow electricity and heat to pass through them. Okay, so that makes option C the correct answer to this question. Question 18. When the temperature difference between the wet and dry bulbs of a hygrometer is high, this indicates that A, it is about to rain, B, the relative humidity is high, C, there is plenty of sunshine, D, the relative humidity is low. So hygrometer is actually an instrument used to measure the moisture content, okay, and it operates on the principle of evaporative cooling. Okay, so if a large difference is recorded between the temperature of the wet thermometer, okay, the wet thermometer and the dry thermometer of a hygrometer, it simply denotes that, okay, the relative humidity is low. Now remember that when relative humidity is low, the air is dry and the rate of evaporation is high. Okay, so when the temperature difference between the wet and dry bulb of a hygrometer is high, it simply indicates or denotes that the relative humidity is low. So that makes option D the correct answer to this question. Question 19. A 3 centimeter cube volume of liquid W of density 200 kilogram per meter cube is mixed with another liquid L of volume 7 meters cube and density 150 kilogram per meters cube. The density of mixture is, so since we are looking for the density of mixture, you can just assume that we just add the density, since we already know the density of the liquid, so we just add both of them and get our answer. Okay, so in this case that is not true, and the reason why it's not true is because density is not a linear quantity. Okay, density depends on mass and volume, so if we do it that way, our answer will be wrong. So let's move over to the board to provide answer to this question. So in this case, like I said, we can't just add the density of the two liquids to get the density of the mixture, since the two liquids are mixed together. Okay, if we do that, we'll be wrong. Our answer will be wrong, and the reason is because density is not a linear quantity. It depends on volume and mass. Okay, so in this case, now since we already know the volume of each of the liquids, okay, but we don't know their mass, so we have to calculate for their mass. But remember that density is equals to mass all over volume. So first of all, we'll calculate for the mass of liquid L. So we just make M the subject of formula. So we write it M subscript L, indicating the mass of liquid L. So we just multiply the density of liquid L by its volume. So if we do that, the density is 200 and the volume is 3. So if we multiply this together, this will be equals to 600 kilogram. Okay, so this is the mass of liquid L. So we can as well solve for the mass of liquid, this is the mass of liquid W. Okay, so we can as well solve for the mass of liquid L using this same formula. Okay, so for liquid L, we'll be having the density is given to us to be equals to 150, then times 7, the volume is 7 meters cube. Okay, so if we multiply this together, we'll be having 0. So we multiply this, that will give us 35. So write down 5, we carry 3. Then this times this will give us 7 plus that 3 will carry, that will give us 10. Okay, so in this case, we have 1050 kilogram for the mass of liquid L. So now we have to calculate for the total mass of the two liquids. Okay, so total mass, let's just say MT will be equals to mass of liquid W plus mass of liquid L. So that will be equals to 600 plus 1050. Okay, 600 plus 1050, and this will be equals to 1650 kilogram. Okay, now we'll also calculate for the total volume. So total volume of both liquid W and liquid L will be equals to 3 plus 7, and that will be equals to 10. Okay, 10 meter cube. So since we already know the total volume and the total mass, okay, we can now calculate for the density of the mixture, since both liquid are mixed together. Okay, so density of the mixture in this case will be equals to the total mass MT all over the total volume VT. So if we substitute our values here, we'll be having 1650 divided by 10. So 0 will just cancel 0. So that the density of the mixture is equals to 165 kilogram per meters cube. So let's return back to the screen to pick the correct answer to this question, and that is option A, 165 kilogram per meters cube. Do you have any question to ask? If yes, please feel free to ask your question by simply clicking on the link in the description below, and that will take you to my school website. There you can ask all your questions, and our team of solution providers will provide answers to all your questions within a short period of time. Moving on to question 20. A body of mass 36 kg falls through a viscous liquid which offers a drag force of 260 Newton on the body. The upthrust on the body at terminal velocity is, so here we are asked to take acceleration due to gravity to be equals to 10 meter per second square. So take note here that for a body falling through a liquid, there are three forces that actually act on that body. So one of them is the weight of the body that acts downward, then the drag force of the liquid that acts upward, okay, and also the upthrust of the liquid that acts upward. So let's move over to the board to provide answer to this question. So for a body falling through a liquid at terminal velocity, mg, okay, minus v minus u is equals to 0, where mg stands for the mass of the body. Like I said earlier on, there are three forces that act on the body falling through a liquid. Okay, one of them is the mass of the body, then the second one is the drag force, okay, or the viscous force, and the third one is the upthrust of the liquid on the body. Okay, so mg stands for weight, which is the weight of the object, but in this case we are told that mass, which is mass, is equals to 36 kilogram, and we are asked to take g to be equals to 10 meter per second square. So we just substitute. Now remember that v here, which is the drag force or the viscous force, is given to us to be equals to 260 Newton. So we just substitute. So here we'll be having 36 times 10, then minus 260, then minus u is equals to 0. So we are actually looking for the upthrust, okay, of the liquid on the object, right? So we just move it to the other side of the equation. So that we'll be having u to be equals to, so if we multiply these two, we'll be having 360, then minus 260, and this will be equals to 100 Newton, okay? So upthrust is a kind of a force too, right? So the upthrust acting on the body, okay, at terminal velocity is equals to 100 Newton. So let's move back to the board to pick the correct answer to this question, and that is option A, 100 Newton. Do you have a better solution or better step to any of these questions? If yes, go to the comment section below to comment the question number and the solution you wish to share. Question 21. The process whereby the molecules of different substances move randomly is called A, capillarity, B, surface tension, C, osmosis, and D, diffusion. So the answer to this question is diffusion. So diffusion is simply the process whereby the molecules of fluid, okay, moves randomly from an area of high concentration to an area of low concentration, resulting in mixing. Okay, so the answer to this question is option D, diffusion. Why capillarity has to do with the ability of a liquid to flow in a narrow space, okay, owing to adhesive and cohesive forces. While surface tension is the elastic force at the surface of a liquid that makes the liquid to behave like a stretched elastic membrane. While osmosis has to do with the movement of solvent molecules through a semi-permeable membrane from a region of low solute concentration to a region of high solute concentration. Okay, but for the purpose of this question, the answer is option D. Okay, the process whereby the molecules of different substances move randomly is called diffusion. So D is the answer to this question. Question 22. The qualities of a good thermometer include, so these are the options that are given to us, reproducibility. So reproducibility is one of the quality of a good thermometer. Okay, so reproducibility has to do with the measured value. Okay, the measured value of the thermometer being consistent under the same condition. Okay, that is, the value of temperature measured with the thermometer should be the same under the same condition, should be consistent under the same condition. That is just the meaning of reproducibility. While sensibility has to do with the thermometer's ability to quickly respond to temperature change, okay, which is also a quality of a good thermometer. Okay, why I will have high thermal capacity. So high thermal capacity is not a quality of a good thermometer, but rather it should have been low thermal capacity. Why we also have high accuracy. So high accuracy has to do with, like, when you compare the value obtained with when you use the thermometer to measure temperature, okay, with those of standard values, okay, it should be close. Okay, that is what high accuracy is all about. Okay, so the quality of a good thermometer include I, and IV. Okay, I, and IV. So that makes option A the correct answer to this question. Question 23. The process whereby a liquid turns spontaneously into vapor is called A, regelation, B, sublimation, C, boiling, and D, evaporation. So the answer to this question is evaporation, and the reason is because evaporation occurs at all temperature. Okay, evaporation do occurs, okay, below the boiling point of the liquid. Okay, why for A, regelation has to do with the effect of pressure on ice. Like, ice melts when pressure is applied to it, and when the pressure is removed, then the ice refreezes. Okay, that is all about regelation. While sublimation has to do with the transforming of solid directly to gas without passing through the entire immediate liquid phase. Okay, while boiling has to do with liquid changing into vapor, but at the boiling point. Okay, it must get to a certain temperature before the liquid can transform into vapor, and that's what referred to as boiling. Okay, but for this question, the answer to this question is evaporation. So the process whereby a liquid turns spontaneously into vapor is known as evaporation. Remember that evaporation occurs at almost all temperature. Okay, evaporation occurs at all temperature. It occurs below, even below the boiling point of the liquid. So that makes option D the correct answer to this question. Question 24. Which combination of the above is evident of the molecular nature of matter? So I will have melting. So melting involves molecular activity where solid transforms into liquid, while boiling also involves molecular activities where liquid turns into vapor. Okay, while combustion, which is the process of heat transfer through molecular interaction. Okay, while I, which is refraction, is just the bending of wave, okay, as it crosses from one medium to another. Okay, so the combination above that is evidence of molecular nature of matter is I, and IV. Okay, I, and IV, and that makes option B the correct answer to this question. Question 25. When very hot water is poured into two identical thin and thick glass tumblers in equal volumes, the thick one cracks because A, of the even expansion of glass, B, glass is a crystal, C, glass is a good conductor of heat, D, of the uneven expansion of glass. So the answer to this question is option D, because of the uneven expansion of glass. So when hot water is poured into a thick glass tumblers, the inner surface of the glass, which is in contact with the hot water, heats up quickly and expand more than the outer surface. Okay, so this uneven expansion of the two surfaces, the inner and the outer surfaces, creates stress, which eventually leads to cracking. Okay, but for the case of the thin glass tumbler, it's not like that, because of the thinness, both the inner and outer surface tend to heat up evenly reducing this risk. Okay, so that makes option D the answer to this question. I believe you enjoyed this video content. If yes, please do not forget to hit the like button, click on the subscribe button, and lastly tap on the notification bell to get informed as soon as we release the next videos.